Hi all, I am K. Surya working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, let us see about circuit switching and its types. Before going into the circuit switching, we need to know what is a switch, what is switching, and what is a switched network. Switches are the hardware or software devices capable of creating temporary connections between two or more devices linked to the switch but not to each other. It's a device which connects multiple communication lines together. So this is an example of a switch and a folded switch. In a folded switch, the output will be connected to the input, and in a normal switch, different outputs will be mixed together inside the switch and it will be exchanged. Say the input 1 may be connected to output 3, input 3 can be connected to output 2, and so on. Next one is switching. A network is a set of connected devices. Whenever we have multiple devices, we have the problem of how to connect them to make one-to-one communication possible. So the solution for this problem is switching. A switched network consists of a series of interlinked nodes called switches. So a switched network is a computer network in which connectivity is provided by using numbers of switches. A fully switched network uses only switches for connecting all the devices used in that network. So this is an example of a switched network. So here the computers are denoted by A, B, C, etc. up to L, and the switches are denoted by 1, 2, 3 up to 8. Next one, we'll go into switching. Traditionally, three methods of switching have been discussed here. So circuit switching, packet switching, and message switching. So under packet switching, again we have virtual circuit approach and datagram approach. The first two are commonly used today, whereas the message switching is not used. So a circuit switch network consists of a set of switches connected by physical links. A connection between two stations is a dedicated path made of one or more links. However, each connection uses only one dedicated channel on each link. Each link is normally divided into n channels by using FDM or TDM. A circuit switch network is made of a set of switches connected by physical links in which each link is divided into n channels. The figure shows a trivial circuit switch network with 4 switches and 4 links. Each link is divided into n is equal to 3 channels, here using FDM or TDM. We have explicitly shown the multiplexing symbols to emphasize the division of the link into channels, even though multiplexing can be implicitly included in the switch fabric. Two n systems A and M may be computers. If A has transmit to M, it will be do through circuit switch networks. The n systems may be computers or telephones are directly connected to the switch. Two n systems are shown here for simplicity. When n system A needs to communicate with n system M, system A needs to request a connection to M that must be accepted by all the switches as well as by M itself. This is called the setup phase of a circuit and is reserved on each link, and the combination of circuits or channels defines the dedication path. After the dedication path made of connected circuits is established, data transfer can take place. After all data have been transferred, the circuits are toned down. So here we need to see about several important points. Circuit switching takes place at the physical layer. Before starting the communication, the stations must make a reservation for the resources to be used during the communication. These resources such as channels, switch buffers, switch processing time, and switch input and output ports must remain dedicated during the entire duration of data transfer until the teardown phase. Data transferred between the two stations are not packetized. The data are a continuous flow sent by the source station and received by the destination station, although there might be periods of silence. There is no addressing involved during data transfer. The switches route the data based on their occupied band or time slot based on FDM or TDM. Of course, there is an end-to-end addressing used during the setup phase. In circuit switching, the resources need to be reserved during the setup phase. The resources remain dedicated for the entire duration of data transfer until the teardown phase. So next, let us see about the three phases in circuit switching, which are connection setup, data transfer, and connection teardown. So connection setup is also known as the setup phase. So before the two parties can communicate, a dedicated circuit need to be established. The end systems are normally connected through dedicated lines to the switches. So connection setup means creating a dedicated channels between the switches. When system A needs to connect to system M, it sends a setup request that includes the address of system M to switch 1. Switch 1 finds a channel between itself and switch 4 that can be dedicated for this purpose. Switch 1 then sends the request to switch 4, which finds a dedicated channel between itself and switch 3. Switch 3 informs the system M of system A's intention at this time. The next step, making a connection and acknowledgement from system M, needs to be sent in the opposite direction to system A. Only after system A receives the acknowledgement, connection will be established. Next one is the data transfer phase. After the establishment of the dedicated circuit, the two parties can transfer the data. Next one is one of the parties need to disconnect. A signal is sent to each switch to release the resources, which is known as connection teardown. Two important parameters here we need to know is the efficiency and delay. Channel capacity is dedicated for the whole duration of the connection. So, if there is no data transfer, then the capacity will be wasted and the network will become inefficient. Next one is delay. Here, initial delay will be high until the circuit establishes a connection. After the connection is established, then data transfer phase will have only less delay. So after the circuit establishment, information is transmitted at the fixed data rate with no delay other than the propagation delay. The delay at each node is negligible. Hope you understood circuit switch networks. Let us take up some assessment questions. A local telephone network is an example of packet switch network. The required resources for communication between end systems are reserved for the duration of the session between end systems in dash method. Yes, it is circuit switching. As the resources are reserved between two communicating end systems in circuit switching, guaranteed constant rate is achieved. Thank you for watching this video.